Ms. Kissel, and I'm going to explain the basics of series circuits. A series circuit is a circuit that contains a battery or some other source of voltage, and then some resistors or light bulbs that are connected in such a way that there's only one path. So for example, this is a circuit with two resistors in series. The current comes out of the battery at the positive terminal, goes around through one, through the other, and then back to the negative terminal. Remember, the direction of current is opposite the way that the electrons move in the circuit. So for example, let's say this is a 12-volt battery, and each of these resistors has a resistance of 2 ohms. If we want to calculate the current in the circuit, we'll use Ohm's law. Current equals voltage divided by resistance. The voltage in the circuit is 12 volts, and the total resistance is 4. When resistors are in series, you just add them like normal numbers. 12 divided by 4 gives you a current of 3 amps. So if you want to draw that, you can draw 3 amps going this way. So the current here is 3 amps, here is 3 amps, here, everywhere in the circuit, the current is 3 amps because there's nowhere for the electrons to go other than around the entire loop. Actually, electrons go this way around the loop, but there's only one path. So the number of electrons per second crossing by this point is the same as the number of electrons crossing by this point in a second. Now, if I want to calculate the voltage of the individual resistors, I can use Ohm's law again. If I rearrange this, I get voltage equals current times resistance. So to find the voltage of an individual resistor, I multiply its current, 3, by its resistance, 2, and I get 6 volts. So this resistor has a voltage of 6 volts, and this resistor has a voltage of 6 volts. They add to the voltage of the battery. The battery gives 12 joules of energy per coulomb of charges, and then this resistor takes 6 away, and this takes 6 away. When the charges get back to the battery, they have no energy left. Let's do another example where the resistors are not identical. Suppose we still have a 12-volt battery, but let's say we have a couple of light bulbs. And the bulbs aren't identical. This one has a resistance of 2 ohms, and this one has a resistance of 4 ohms. We can use Ohm's law to calculate the current. Current equals voltage divided by resistance. 12 divided by total resistance is 6, gives me 2 amps of current. Now, if I want to calculate the individual voltages, I'll do voltage equals current times resistance. For the 2 ohm, I'll do current 2 times resistance 2 equals 4 volts. For the 4 ohm bulb, I'll do current 2 times resistance 4 equals 8 volts. The total adds to 12. All right, you try this one. Figure out the total current going around and the voltage of each resistor. When you have it figured out, start the video again. Okay, first I'll find the current coming out of the battery. Voltage, 24, divided by the total resistance, 2 plus 1 is 3, plus 5 is 8. So we get 3 amps of current. Now to find the individual voltages, I will say voltage, current times resistance. This one has a voltage of 3 times 2 or 6 volts. This one has a voltage of 3 times 1, 3 volts. And this one has a voltage of 3 times 5, 15 volts. 6 plus 3 plus 15 equals 24, the voltage of the battery. Now I want you to try this one. In this case, you already know the current. I want you to find the voltage of the battery and the voltages of the two resistors. First of all, I'll find the voltage of each resistor. Voltage equals current times resistance. So this resistor's voltage is current 2 times resistance 2 equals 4 volts. This one's voltage is its current 2 times its resistance 10, 20 volts. Therefore, the battery voltage must be 24 volts. We can check this because the total resistance of the circuit is 12, and the current must equal the voltage of the battery divided by the total resistance. 2 equals 24 divided by 12, it works.